Good morning. Welcome to the first session after keynote. The first session of NDC Security. I hope you like keynote. Did you? Of course. I was also there. Very nice. I love it. And I hope this session won't be disappointing. My name is Sergey, and I will be a presenter for this session. This session is called Pentesting Azure Container Services, where I'm going to show you how can we find misconfigurations in different in containers when you run containers in the cloud. To be fair, it could be done in any other cloud. It could be done even on premises, because initially this session was created for on-premises environment, but it works in Azure, and I will use Azure examples to show you how it can be misconfigured. So before I start, let me say a few words about myself. So I'm a consultant, instructor, conference speaker. You can find my sessions at Black Hat in London, Black Hat Europe, Wild West Hack and Fast, Hack in Paris, and many other conferences. I also work with customers. Usually what I deliver is something I found when I work with customers. So I work in consulting, and I also provide trainings to customers as well. I have certs, a few. I have certs, my custom MVP and many others. But the key here, what I want to point here, is that I prefer live demos. So you won't see many slides in this session. Is that okay? So I have few slides. Most of the time, I will show you live demos. So just slides to show you general picture, then jump to demos. Of course, when I show live demos, when everyone show live demos, something can go wrong, right? Just in case. So I hope everything will be fine, but when I delivered the session, I made one stupid mistake. I decided to, just right through the session, restart Kubernetes. It took 10 minutes when I had 40-minute session. This time I will not repeat this mistake, but just in case. Something might happen. All right, so anyone here work with containers? Probably if you are here, yeah. And those containers probably hosted in Azure. Good. So what I would like to show you, what can go wrong if we work with containers in Azure. Before I show you that, probably this slide will be very, very, very simple for you. But just in case, for those who doesn't work with containers, I want to just give you a complete, brief picture how containers work in Azure. So first of all, before we deploy a container, we need to create an image. So to deploy a container, we need an image. After that, we push this image to container registry in Azure, which is called ACR. It will be stored there. Then, when we want to deploy a container, we want to deploy it somewhere on container instance or container apps, which like a new service, or Kubernetes. More often, we use Kubernetes. That's the most common and production ready. Also, what we like about Kubernetes that we can move containers between locations, and if you have Kubernetes installed somewhere else, you can also it will be more portable. So, is that clear? I'm not talking here about pipelines and automation, right? So just the basic steps we need to take. Yeah, of course, normally we automate with pipelines. Now, what can go wrong if we work with containers in the cloud? Let me show you first one of the most typical thing, the most low-hanging fruits we can find when we pen test. By the way, quite often I pen test, and in pen test, first of all, we're trying to find something which is really easy to compromise. And the first thing that quite commonly can be found is kubectl credentials. So, anyone use kubectl? Yeah, yes. Me what? Oh yeah. Nope. Better? Yeah. Near. come here and help. Is it perfect? If not, all right. So kubectl credentials. kubectl credentials. Anyone work with kubectl, or you do it from the portal? Of course, no. So kubectl. That's the tool we have on the machine. So let me just try to do some basic things with kubectl. I'm going to go to the folder called kubectl, zoom it for you, and let's run something like kubectl get pods. And I can see pods right away. No authentication, no asking for credentials, nothing. All right, let's try to do the same on a different machine. Oops. Oh, AZ this time. And let's wait. It should fail, so it will take a bit longer. Still better than the restart Kubernetes, but it takes time. And so, yeah, but it's not working. So it's not working. Similar machines, but on one machine, I was able to run command without any authentication, without any questions. On a second machine, it asked me for, this doesn't even ask me about credentials, just say that I cannot do it. So somewhere credentials are stored, right? Nowhere? Yep. So if you go to user profile, so here I can't really have really good zoom, but after I find it, I will zoom it. So I'm going to user folders, current user, and so here we have a folder called .kube in the user profile. So if I just simply copy and paste this folder from one machine to another, so copy .kube to another machine, shouldn't take long. Not that bad. All right, try again. Yep, it's working. Now, after that, when I can see those, all of those pods, what I can do, I can, let me find out the new name. Azure Front, oops, connect to it. And so I'm inside of container. That's the easiest, let's call it hack. Not really hack, but something that pen tester or attacker can find on the machine. So I will give you a bit later recommendations what to do, but I guess you have some ideas. So first of all, the workstation itself that you use to connect to Kubernetes must be well protected. All right, so this is the most simple compromise that I'm trying to find right away when I start to work with like customer. But I don't want to finish my session right now. It should be something else. So another example of compromise will be more complicated, and most like for the rest of my session, I will show you that, is how container image, if container registry is not protected perfectly, how container image can be compromised, modified, and then can give all keys to Kubernetes environment. So if container registry doesn't have correct permissions, so for example, user may have permissions assigned on the subscription level or resource group level and inherited on container registry. So if someone can pull images, so download images from container registries, what they can do, they can modify them. It's quite easy. If you can download image, you can modify this image as well. Then you can push those images back to container registry. Not you, but attackers. So after that, companies just normally with their pipelines deploy containers and Kubernetes or container instance, or container apps, doesn't matter. But in all of those cases, containers on those environments will be Trojanized. As the result, attacker will be able to have access to that environment. From here, demo. So let me close that. Close that. Close that. All right, so let me show you what I have. Let's start from container registry. It was there already. Oops, that's too much. So I have container registry called azhack. Here I have a repository called hello.w. On purpose, I made a mistake just to make sure that it's mine. Hello.w. And, oh, you know what? You know what? Probably it's already Trojanized. I think I forgot to remove the previous version. All right, anyway, so it's quite similar. Then on my workstation, that's my attacker machine, I have Docker. Docker installed. Now, let me start from the beginning. First step is to navigate to the folder and download container image from repository. So let's do it real quick. First of all, I would like to pull and save it as the file. Save it as the file. And it says no such image. Authentication required. So in this case, because I wasn't authenticated, let me say ACR login. And after that, yeah. Now I can download container. It might take time. Let me break that. And one more time. Oh, come on. I don't believe you. Oh, let me check. Maybe it's downloading, in fact. Nope. But still waiting for something. Oh, finally. No? Yeah. No? Yeah, probably now it's downloading the image. Yeah, it is. So as I mentioned before, it takes time. So now we're downloading the image in the file. So we need to wait like maybe around a minute or so, and then you'll find out the image. Anyone tried to do that before, like download images as the file? Because quite often when developers or engineers, they work with images, they don't really know how it looks like after it was already pushed into registry. So if you look at the file, now I download that without any extensions. But if I add an extension, or I can just open it with 7-zip without even extensions, look at that. It can be opened with like 7-zip. Let me extract it real quick. All right, so now, and I know you can see it well, but there's a number of folders. If I open any of those folders, let me just open this folder, for example. In every folder, I will find out layer.tar. Let's open layer.tar. And here I can find the actual content. So here I have HTML page of my container image. So all the files can be found there if you download the image. By the way, also I have here a backup of original and Trojanized, just in case. So if you don't mind, I'm going to remove this original, because that was probably already Trojanized. Let me just keep it for now, but I'm gonna, let's call it 1, and this one will be also 1. No? Okay, it's already opened. And let me open this hello original. It's definitely not Trojanized yet. So, and let me extract it as well to folder like here with the name hello or original 1.2. All right, so let's take a look. Every folder I open, I can find out layer.tar, which contains file. That makes sense? So that will be our container image and all the content of container image. So what I can do next, I can take any of those layers. So for example, let's take that one. I can take any of those layers, open it up, and let me extract it. Extract the layer tar. What do you think? What can we do next? If I extract this folder, what can be my next step if I would like to Trojanize this container image?
Inject malware bars, maybe?
Yeah, so inject malware. I need to drop something that will run automatically, some kind of malware, depends what I want, something that should run automatically. So what I did, I create shared library, shared object. Let me show you that real quick. So here's my shared object called reverse_shell, that shared object. So that should give me what is called a reverse shell. We here all in security, right? You all know what a reverse shell is, right? No? Okay. Did you hear about Command Control Center, C2? So attackers, when they want to control their victims, they need somehow they must do it somehow. So the most common way to control the victim is to run something on the victim side. So like motivate your victim to open the malware, Trojan, like macros, and then the victim will give you a shell to his or her computer. This is called a reverse shell because not from attacker to victim, but from victim to attacker. So I'm a victim and I send a call to attacker. That's called the reverse shell. So I allow to control myself from outside. That's a reverse shell. So I developed this object, reverse shell, that shared object. I'm going to take this folder, copy it, and place to where it was. Here, yeah, to here. Doesn't really matter where, to one of those folders. Now, before I zip it again, I need to find out the hash of the old layer.tar. You will see soon why. For now, it may not be very clear, but soon you will see why. Layer.tar. So let me copy this hash. And now I can safely remove this file. Old layer. And let me zip, like not really zip, but in a tar format. New layer. And remove the folder. All right, so now we have layer.tar, let me open it up, with Trojan. With Trojan. That's not enough. Now we need to run this Trojan somehow, because at this moment, Trojan just was placed on the disk, physically on the disk, but we need to run also that Trojan as well. So next step is to go to the root. No, I don't want. And open, not really this one, but this file. And open this file. So I know it looks a bit messy, but if you look at this line, you will find what is going to run with this image. So if I add more commands, it should also run my image. So my how's it called? Trojan. One moment, I'm gonna copy that from existing, from example JSON. Come on. Damn it. So, look, right after apache.pid, I had ld preload plus my reverse shell accept arguments. There's a first argument, my IP address. So that's the IP address of attacker. So my IP address of attacker. And, where is that? A remote port. That's the port number that attacker listening on to accept connection. Of course, in the real world, we don't use port 4444. It's only for demos. Why we don't use 4444? Yep. Non-standard port. There's a high chance, first of all, it could be blocked. Plus, it looks suspicious, right? So when you monitor the network, or maybe not you, but like some of from your colleagues, when they monitor the traffic, they find port 4444. Oh, what is that? So it's not standard. So usually we use 443, which is the most common port. Anyway, let me copy that. And paste to my file. We're almost done. There's one more thing we have left. Do you remember we copy and paste this hash? So if you look down below, you will find out that some kind of hashes. So those all the hashes of previous layers. But because I made a new layer, hash is different. Let's find out the old hash. So this one is the old hash. So we need to change this hash to my new hash. Let's do it real quick. So first of all, I need to find out the new hash. Also, you may notice that my hash that was PowerShell gave me in uppercase, and here hashes are in lowercase. If I leave it in the uppercase, it will give me an error later on. So let me switch to lowercase. Let me change it to change case to lower. Oh, convert case. Where is that? Here. Convert lowercase, copy that, paste here. That's my new hash. And now let me place this hash into the file instead of the previous hash. That's it. We are all set. Image is completely Trojanized. Let me save it. And the first thing I want to do, I would like to test it locally in my Docker environment. So before I push it to registry, before I do anything else, I would like to test it. Let me close that. Close. Let me test it. So first, I'm going to run my listener on the port 4444. And let's try to build the image here. Let me close everything here. Oh, sorry. Before we build anything, what I need to do, I need to, of course, zip it. Let's call that hello troch.tar. And now we have it. Go back. Oops. So now let's open CMD. Zoom for you. Go to containers. And now what I would like to do, I would like to import this container image. So that's why I would like to use Docker load. Yeah. Oh, yeah, forgot this extension. And let's see. So now we have container image. And the next step is to deploy container. Okay. So next step is to deploy container. I'm going to say docker run. And fingers crossed. Nothing. Error. Oh, pool access denied. What? Unable to find image. Hello, W. Oh, sorry. My bad. There's a different name. I didn't change it in my notes. So that's the right name. Because it was pulled from container registry, it has the different name. So let's try docker run. And yeah, look at that. Where am I? In container. If you look at the IP address, 172.101 and so on, so you may compare that with my current IP address. That's the same. So now locally, I have a remote access to container hosted on that machine. Make sense? All right. What will be the next step? Let me go back to slides. So now we are here. Oh, no, sorry, not yet here. So almost here. We pull the image from container registry. We Trojanize the image. Now it's time to push this container image back. Of course, if we have permissions, but I assume we have permissions because that's one of the things to convince you that you should be careful with permissions. All right, let me go back. Now, let me close that, or just close it. Let me kill the container. All right. Now, next step I would like to do, let's take, is to push this image. To be fair, this image should be already in the cloud, but let's push it. It already exists. Something was pushed, but not a big difference. Now it was pushed to container registry. If I go back to container registry now, let's go back to repository, click refresh, click on that. And I can see that the latest version was pushed just a minute ago. By the way, I live in Portugal, so my time zone is a bit different. All right, so what should we do next? Next step is to deploy container. So this part normally should be, oh, they told me not to go too far because I will be out of camera. This part can be done by company without attacker. So now you have pipelines, or maybe you want to do it manually, I don't know, probably a pipeline. So now your pipeline can do it for you automatically. Yeah, of course, normally pipeline should also start from the building images, but it depends. All right, so let's try to run it. First on something small, like container instance, because that's the fastest way to deploy container. Let me quickly deploy container instance. Click on create. Anyone here use container instances? Yeah, not too many. So it's more for dev and test, small projects, or maybe extension of Kubernetes. But then we'll switch to Kubernetes. Let's start from container instance. I'm gonna deploy new ACI. So my image source will be container registry. Take an image. And the latest, yeah, latest is fine. I have only this one. Click on create. Oh, one more. Before I do it, let me configure the listener. Create. Let's see. Cross your fingers, because now we should get access to, this time, Azure part of Azure infrastructure, Azure PaaS service. Let's see. It's still creating. Nothing so far. Oh, here we go. So this is definitely Azure address from Azure. Let's check. Whois.com. Microsoft. This time we got a reverse shell to PaaS service from container instance. Let's see what I can do here. Whatever I like, to be fair. I can navigate. I can check what is around. Like if we have this tool, yeah, we do. So here's the IP address of the container instance itself. The problem of container instance, for me at least, container instance most of the time deployed standalone, right? That's how we use it, standalone. So dev and test, we don't deploy that as the part of infrastructure most of the time. So if I compromise container instance, it won't give me much. That's why I told you I just want to test. My goal is to get access to Kubernetes. So now let's do the same in Kubernetes. Let me switch to the machine. I prepared YAML file for you. Where is that? I think this one. Yeah, this one. And let's try now to deploy it on Kubernetes. Come on. Create. Apply YAML. Apply. Fingers crossed. Now I would like to get access to Kubernetes. Hopefully, yep. Kubernetes. Now, our application deployed on Kubernetes, and let's take a look what we can do with that. So hello W on Kubernetes. Oh, by the way, what is also important? For companies, for users, it will look just pretty standard. So for example, let me just find out container instance real quick. If I take an IP address and just open it in the browser, nothing. So, oh, yeah, just a hello world. I mean, the application itself is working. So for companies, that will not look suspicious. It will not break the application. Now, I have access to Kubernetes. What should we do here? First of all, let me just try to explore. I don't need any more. Let me try to explore what do we have in Kubernetes. So first of all, I need to add path variables. So my commands will work properly. Next step, I would like to check if any tokens can be found locally in the container. So when you work with Kubernetes, in every container, you will find this token. So if you look at this path, run secrets, Kubernetes, service accounts, and tokens, you will find JWT token. Let's quickly explore this token. Place here. Now we can see this token audience is only this Kubernetes. Okay. So I can also check, none before. Yeah, it's pretty hard to calculate yourself, but if you look at the claims, you can find out that, none before, but the expiration will be next year. So this token will be valid for a year. All right, let's take a look. What can we do with this token? Let me take the token. Before that, let me install curl into container, because I need a curl to use it. Should be pretty quick. And while waiting for the curl, let me add this token. So my next step will be add variable called token. Oh, come on, curl. I told you it might take time. Finished? Nope, not yet. By the way, also one more thing. Since you told me that you don't know much about reverse shell, reverse shells are not perfect. So input, output in the reverse shells maybe not perfect. So sometimes I even don't know when the installation finished, just because a reverse shell is not the same as is normal administration. All right, let me add this token. And by the way, I can't clear the screen. I know I would like to clear the screen for you, but I cannot. So I add the token variable, and next step is to try to use this token to access APIs on Kubernetes. And no. It used to be, but no, not anymore. So Microsoft also makes some progress on that, because like for some time ago, I was able to do it through curl using the internal IP address. Let's try this external name. And forbidden. So in the past, just why I'm showing you that? Because in the past it was possible, but now Microsoft make changes and restrict to enumerate APIs with service account. So they make changes. All right. So I couldn't find anything on the API node with my credentials. But what else I can do? I may find other containers on this Kubernetes server. So for example, let me just show you that in the interface so you'll see it better. If I look at the services real quick, I can see here there's an application Azure Vault. Do you know Azure Vault application? Oh, come on. Never heard of that? Because this application Microsoft used for years to demonstrate Kubernetes. Yeah? Never? Yeah, if you just Google real quick, Azure voting app, you'll find the like step-by-step instruction how to deploy it, and you can find out the image in the MyCast repository. So what I would like to do, I would like to find internally these containers in Kubernetes from my compromised container. So if you see here, we have internal IP addresses. What I would like to do now, I would like to install tool nmap, quite famous tool for enumeration. By the way, it might take some time. But while we're installing. So you can see here, by default, all containers on Kubernetes, they will just have private IP addresses, and possibly they can access each other. Maybe we'll see. So we have private IP addresses for my hello world. I have private IP address for Azure Front, Azure Vault backend, front end. So they are all in the same network. So maybe I will be able to access other containers from my compromised container. Let's test. Hopefully. Oh. This socket isn't working. Anyway, I hope I'll have enough power. We'll see. ID. Okay, so probably, let's see, something else. Yeah, so it was installed. Next step is to run nmap scan. Anyone try nmap? Yeah. Oh, this tool you know. So normally, of course, in a normal environment, normally I need to run in the whole network and find out all of the IP addresses, like nmap with network -sn to find out all live hosts. But for now, because it's demo, I don't want to make it too long. Let me just assume we already found IP address of the victim. All right, so that will be our backend. And for the sake of time, I will specify the port, which is open. And also we need to turn off pinging, probing. So let me run that. And look at this. So I was able to access, I was able to find another host. And I found that this port was open. Anyone knows what this port is? No? No ideas? Port 6379. Known as for Redis. So that's the database, Redis database. Now next step is to get some quick Redis tools. Come on. Shouldn't take too long. And connect to Redis here. Authentication won't be required. So let me copy that. Let's see. Yeah. So maybe already there. Let's type info. Yes, this is from Redis. Let's type keys. So we have two keys. Let's see both keys. And we have keys, cats and dogs. Let's check. Cats and dogs. Let me vote for cats. And say get cats. I can see one. All right, let's vote one more time. 2. So now I have access to Redis database. And so before we finish this offensive demo, because we need to reserve some time for what to do with that, let me ask you for help. Can you please go to this application and start voting? Sockets. Oh, yeah. I can see it in the real time. Well, let's check what we have here. Oh, not too much. Someone press reset. All right. So, thank you. Thank you very much. All right, that was the offensive part of the stop. All right, that was the offensive part of the demonstration. And now the last question we have is like, all right, cool. What should we do? How can we fix it? And there are some mitigations I can offer you to fix the problem. First of all, you should always consider the principle of least privileges. I know you can hear it everywhere, right? You go to every conference, you listen any webinar, they tell you principle of least privileges, and you always say, yes, of course. Yeah, we know that's important. But to be honest, all right, I'm not going to ask you personally, but to be honest, when I work with customers and every customer say, yeah, we know about principle of least privileges, but when we start to test, we find that they have so many misconfigurations and so many violations of this principle. I know it's quite hard to configure everything according to this principle because in that case, you should be very, very granular. You need to test a lot because sometimes you will not have enough permissions. You need to test again, and something may get failed in the real in the production. And that just in case you configure more permissions because it will definitely work, right? But from the security standpoint, that's not the best idea. Next one, and that will be the best, the easiest fix you can have right away, is to use private links. Just turn off public access to container registry. So let me go back to container registry real quick. And if I look at the networking, so here I can see that by default, I can access container registry from every network, so from all networks. The question, do you really need that from every single network? So there are a few options you can have. So option number one, you can completely disable public access. I would say that's the best option. That's the most secure option. And only configure private access. I guess you heard about private links, right? So in that case, only your Kubernetes or whatever it can be, that integrated virtual network, will be able to access this container registry. So that will be a very quick fix for most of the problems. So in that case, attacker needs to compromise your virtual network first before they can access to your container registry. So that's much harder compared to just have public access. So if you can, but if you have something like on-premises Docker or Kubernetes, so something outside of Azure that you cannot integrate with virtual network, what you can also do, you can whitelist your public IP addresses in that manner, and from only those public IP addresses, you will be able to have access to container registry. Still better than all networks. That makes sense? Yep.
Oh, yeah. My question was just the range.
Yeah, of course, you can use the range. 62, not the best idea, of course, but doable. You can do it like that. Or let's make it useless. Oh, no, it's not working. Nice. I cannot do it. I can't make it useless. All right, so there's one big downside of this feature. This feature will work only if you have a premium pricing tier for your container registry. So with basic and even standard, it won't be available. With basic, definitely. Standard, I think so. I think either. And so you must have premium tier for your container registry. All right, so next fix I can offer you is to have separate workstation which is called PAW. Usually we call it for stations for administrators. PAW, Privileged Access Workstation, to deploy to work with kubectl, and in general work with Kubernetes. So do you remember in the beginning I showed you this easy hack with stealing credentials? So the workstation you use to access Kubernetes must be really well protected, not the workstation you use to access Facebook or whatever it may be. So separate workstation to access highly sensitive service. So developers, administrators that work with Kubernetes, they should have separate workstation. And this workstation, of course, must be well protected. All right. Sorry. Where's that slideshow? All right. So next one will be a bit more complicated, and I will not show you full demo. Otherwise, we will run out of time. Content trust and image signing. What you can do, you may sign your images with certificate, and only those images will be trusted. So your container registry won't be able to. So you won't be able to push something which wasn't signed. So you need to go to. You also must have premium tier for your container registry. You go to content trust. You must enable content trust here. But that only will be a first step. Then you also must issue keys. You also, when you build the images, you must sign it. So it will be more hassles. I know, more hassles. But as the next step, you can consider that. Quick fix will be just block network access from outside, but that will be like a next step. Sign your images. Anyone have images signing process? One. Thank you. So hopefully next time I'll see more hands. All right. Next one will not be like really the fix for the problems I show you, but Defender for Containers has vulnerability scanner built in. Yeah, it will not find a Trojan because it wasn't a vulnerability. But if the image is vulnerable in general, it will be able to find it. So let me show real quick. I'm going to go to Defender for Cloud because that's the part of Defender for Cloud. Workload protection. Come on. Container image scanning. And now I see some vulnerabilities. So my container image, for example, is based on the really old operating system, Ubuntu 16.04, which of course is deprecated. So we need to change the base for my image. So it can find vulnerabilities, not really my Trojan, but vulnerabilities. Then avoid root permissions. Root permissions, that's obvious when you build containers. And finally, one last thing, network policies. So I think we have 5 minutes left for Q&A. Network policies. So network policies allows me to control which container can access other containers, how containers can access each other. Because by default, all containers will be in the plain flat network, like just in the flat network. So I will be able to access from one container, I will be able to access other containers. So with network policy, you can control it. So you may say, this group of containers can access another group of containers. So you may just build the layers between them in Kubernetes. That will require you to use, how's it called? Kubernetes network must be integrated with Azure Virtual Network, but it's worth it from security standpoint. All right, so that's some recommendations I can give you. And we have also 5 minutes left for your questions. So your questions. Yes.
Could I like manage everything in a pipeline, the mitigation, so we only give the ACR push permission to a particular self-host domain, which then you need to break into that in order to...
Yeah, so in the pipeline itself, you can also have additional controls. Exactly. So when you have a pipeline. Here I'm just consider that like a bit out of pipeline for the manual process, but yeah, in the pipeline you can also add more verifications. Thank you. Yes, you're first, and then your hand was first.
So the lateral movement within AKS, it would be limited to the namespace, right? By default.
Yep. So, yeah. In my case, was everything in the default namespace, and everyone can see each other.
As long as you isolate namespaces or separate namespaces.
Yeah, then you can physically isolate them. That would be definitely better. Thank you.
Do you have any experience with the OpenShift environment?
What do you mean if I have Kubernetes in OpenShift or any other locations? I would say less experience than with Azure, but initially with OpenShift specifically, no. But with Kubernetes on premises, yes. So not deployed on not OpenShift, but just deployed on the server. So Kubernetes in the on premises work in the same manner. So I show you with Docker, right? So when I was able to deploy it in Docker and I get a shell, so the same will be in Kubernetes on premise. If you deploy the Trojanized image in the Kubernetes on premises, you will get a shell in the same manner. You're welcome. Yes.
You don't mention referencing the Docker image using the hash in your YAML file. Wouldn't that kind of mitigate the whole issue? If you don't use latest instead the complete hash of the Docker image, because that would be different after you kind of analyze it.
Do you mean the hash of the Docker image? You want to do it? What do you want to do with that Docker image hash?
When you reference the Docker image in your YAML file, you say like the low latest or something version. You can also reference using the hash of the complete image.
Could be, but hash will be a little bit different every time when you push.
Yeah, but when you upload the image, then you want to know that you have a different version. You know that you're sure that you're actually using the correct version.
Could be. So yeah, because substitute hash will be pretty hard. I would say impossible. Thank you. 2 minutes left. If you have questions, you may have them. Oh yeah, one more question.
Would using a stripped down container image prevent any of these minimize that access? They don't have any access to RPM or any.
So I would say the best you can do, even the container instance, right? Container instance. The same as Kubernetes. When you deploy container instance, in networking, you can also say if that's a public or private. But that's probably it. So it's more about like access control and network control, and not too much you can do here. If attacker already own the image, then there's not too much you can do, because you cannot really predict everything that attacker could do. So if they place file here or there, or it will be reverse shell or some other kind of Trojan. So you must make steps before your container instance was compromised. And maybe the last question, if you still have them. If not, you can just grab your fruits and coffee. All right.